Here is a vertical hydraulic press. The operator has to reach between the tools of the press after each cycle. If there is a fault with the vertical hydraulic press, the operator is at risk of a crushing injury. The press could fail for two main reasons. Firstly, the press tool falls by gravity because the flexible hose attaching it to the machine fails, or because the press tool becomes detached, or because the hydraulic valve fails. Or secondly, there is an unplanned powered stroke of the press because there is an electrical fault, or because the hydraulic valve fails. Although it is hoped that the machine won't fail and that the operator won't be injured, according to the data, the operator is at risk 20% of the time that the machine is operating. Due to this 20% risk of the operator being injured when the machine is working, the organisation needs to know how frequently this is likely to happen. One way to estimate the probability and frequency of an event occurring is to use fault tree analysis. Fault tree analysis identifies potential causes and pathways to a top event failure. And, if probabilities can be allocated to the basic events which potentially lead to the failure, the probability of that top event occurring can then be calculated. We know that, according to estimates, there is a 20% chance of the operator being exposed to the risk of injury when they are using the press. To use the probability of this happening in the fault tree, we need to convert 20% to a decimal. 20% equals 20 divided by 100, which equals 0.2. We have data for the frequency of failure for the different parts of the machine, and also whether the effect of this failure would cause the press tool to fall by A, gravity, or by B, an unplanned powered stroke. We have all of the information we need, so now we can construct the fault tree. Let's start constructing the fault tree by recording the undesired top event, which in this case is the crush injury. For the crush injury to occur, the operator needs to be working on the machine and the tool needs to fall because of a failure. So these are recorded in the fault tree at the next level, second level, joined to the top event by an AND gate. At this point, we aren't going to explore the operator exposed any further. We're going to focus on the reasons why the tool comes down as a result of failure. We know that there are two reasons why the tool might fall, either because of a fall due to A, gravity, or because of B, an unplanned powered stroke. These are recorded in the fault tree at the next level, third level, joined to the second level event by an OR gate. We know, from the information we were given, that each of these third level events have several potential causes, so these are recorded at the next level, fourth level, using OR gates. The gravity fall could have been caused by detachment of the tool, or hose failure, or valve failure. An unplanned powered stroke could have been caused by an electrical fault, or valve failure. We have now constructed the fault tree from all of the information that we have been given. This fault tree shows the top event and all of its potential causes. Now we need to add the frequencies of these lower level events happening to the fault tree in preparation for calculating the frequency of the top event happening. The last bit of information we need to add to the fault tree is the probability of the operator suffering an injury. As we said earlier, we know this is 20%, but for the fault tree calculations we need it as a decimal, which we calculated as 0.2. Now we have constructed the fault tree and it has all of the data we need, we can work backwards from the lowest level event and calculate the likely frequency of the top event, the crush injury, happening. If you want to have a go at the calculations yourself, press pause now, then press play when you're ready to move on. Let's start with calculating the frequency of the gravity fall and the powered stroke occurring from the information we have been given about the fourth level events. The frequency of the powered stroke occurring can be calculated by adding together the frequencies of valve failure and electrical fault occurring. The frequency of the fall due to gravity occurring can be calculated by adding together the frequencies of valve failure, hose failure, and detachment of the tool. Now we can calculate the frequency of the second level event occurring, the tool coming down as a result of failure, by adding together the frequencies of both potential causes, the powered stroke or the gravity fall. Finally, the frequency of the crushing injury occurring can be calculated by multiplying together, because we are using an AND gate, the probability of the operator being exposed and the frequency of the tool coming down as a result of failure. We have used fault tree analysis to calculate that the operator is only likely to be injured in this way once in every 10 years. As this video has hopefully demonstrated, fault tree analysis is a technique that focuses on an undesired event or system failure, top event, and aims to determine all of the ways it could occur. If the probability of the lower level events occurring are known, the probability and frequency of the top event can also be calculated.